Hello, everyone. So just to give you a quick summary of what I will be covering today, Andy has already talked to us about what's driving big data growth. A lot of you guys have heard of big data. There is a lot of confusion as well out there. It's an evolving field. I'm not going to add my own perception to that to add to the noise. I'm going to focus on what we are hearing from our customers and primarily try to address the challenges that companies across industries are currently facing in adopting big data. Of course, Hadoop is there, the technology is there, and lots of new technologies is driving big data, but there are a lot of challenges that companies are facing, and I'll try to focus on that and how we are trying to address those challenges. And our experience has been across industries, so that kind of gives you a good picture of what's going on in various areas and which industries are actually doing better than others. But before I get into that, just a quick summary of what we are about, CrowdANALYTIX, because it is a new concept, and just want to quickly explain that to you guys. We now have a community of data scientists. As Richard mentioned, this is a scarce resource. We have people across 50 countries. More than 3,000 of them are now aggregated on our platform and are available for us to solve any data analytics problems. Now, there are problems that are, as far as the data is concerned, it's clear what you want, the problem definition is right and known. But there are many problems out there right now because this area is evolving. It's very difficult to know, firstly, how to even define the problem, how to identify which data sources to utilize. If it is the advertising you're talking about, if you want to predict a customer's behavior, which data sources are important? It's not an easy question to answer. Not only that, a data scientist has one perspective, right? He might be a great guy, but he still has biases. We eliminate those biases by getting the community to compete against each other. So any project held on our platform is held as a competition. And you will find hundreds of data scientists competing independently, coming up with solutions. And the best of those solutions are then delivered to the customer. So that's our process. We primarily look at public data because it's most of the data, by the way, the big data that you look at, most of it is publicly available. And the rest of the transactional data has always been there. So we try to focus on that. There is climate data, there is data on parking lots, there's data on accidents, crimes, real estate, social media. All of this data can give you immense amount of knowledge about companies and actionable insights. So that's the process we use. Just a quick thing on how it works. So any customer comes to us, there is a discovery phase. We engage with the customer, understand his problem. As I said, the biggest challenge is translating a business challenge into a modeling challenge. The two guys don't even understand their language, each other's languages. So for example, a data scientist is thinking in terms of modeling, and a marketing guy, and I have seen this across industries now, marketing guy is not able to communicate his thoughts in a manner that a data scientist understands. This communication gap is what we fill through our solution managers. Once the problem is translated from a business one into a modeling one, this is then posed to the community. They come back with models, which we then package again as actionable insights for these companies. So a marketing guy is more interested in prediction of what a customer wants to buy, or he wants to know what is the ROI of his marketing mix, what is the most optimum mix that he should be utilizing. And the data scientist is thinking in terms of what data sets to utilize, how to clean up the data, how to merge different data sets. We fill that gap, okay? Now, this is a quick snapshot of the kind of people we have. So, yes, resources are scarce, and scarce across US and India or any other part of the world. This is common. Why is it scarce? And Andy will probably agree with me. Many of these mathematicians don't really want to be associated with one type of problem. Okay, this is They would rather remain horizontal. They're thinking numbers. To them, predicting the condition of a heart is the same as predicting the quality of wine. They don't care, and they would rather remain independent. So the best guys are independent consultants, and we've just aggregated all of them. Just a quick thing on how algorithms get optimized, right, on our platform within a very short period. So Andy talked about speed to market. Think of it as parallel processing of the experimentation process. When you're doing a new big data analytics, there is a bunch of trial and error phase that you go through. This happens in all industries, all organizations. When you're running a pilot, you will, the first step, you build a model, you try it out, you tune it, you test it on real data, you go back and do it all over again. If you're doing this with one data scientist, it takes a while. And that's one of the reasons the cycle times are as big as 12 months to 24 months. We are parallel processing this entire process, okay, of testing, trying, and tuning. So every time a model is developed by any of the data scientists, we update a leaderboard with their, in case of predictive analytics, we would have a prediction error, which clearly says how good or bad their algorithm is. Okay, the moment that score is on the leaderboard, the next guy comes and tries to beat it. Okay, this process is repeated. The benchmark keeps moving because it's a live public place where you're on display, and just like many of you, you want to do better than your peers. Okay, so the moment, let's say a guy in the US was on top of the leaderboard, by the time he wakes up in the morning, some guy in India or China has already beaten him, and then he wants to go back and do that again. This process is what
while they're asleep.
Exactly. So that is what is shown by this curve, which shows how quickly, within 4 weeks, we reach a point where no further improvement is possible in the model, and this is the algorithm that gets developed and delivered to the customer. Okay, why is all of this required? Algorithms exist. Okay, there are 50 or 60 types of different algorithms across machine learning and statistics. There's nothing new about that. That's existed for a while, and it's been derived from artificial intelligence, the field of artificial intelligence, and there's just enough algorithms out there. What you feed into the algorithm is just not a science, it's an art, okay? And that is what causes all of these variations. And it's amazing how you see these variations, right? And, when you test it out on the platform. So just quickly, so that was a quick intro on how we do it, but I just want you guys to see where big data is as far as we are seeing, right? From discussions with companies doing fraud analytics, patent analytics, customer analytics. We've done climate analytics for prediction of flood. So we have a broad, experience. We've now executed about 40 competitions. This is where the industry is, okay? So people like Cloudera have ensured that the only thing Cloudera is doing is scaring the hell out of you and telling you, I hope
that's okay.
Those guys are not there.
No problem.
Okay, so what they are doing is they're telling you, look, you need to keep all of your data, okay? It could be data created by your video or audio or anything at all that you've been throwing so far, or putting into your magnetic tapes, they need to be on your Hadoop server. Why are they doing it? Because unless you reach a scale of 1 terabyte or more, Cloudera is not needed. So what are they saying? Right, this is basically where it is, okay? I'm not exaggerating at all. So stop, when you're vacuuming your place, stop vacuuming it. Keep all the dirt with you. You never know, there could be a gold particle there somewhere that you are throwing along with the dirt. This is what Cloudera is telling people, okay? Now, post that, and this is where everyone is. So the fraud analytics guy, there are banks, they will say, look, before I didn't have all the technology and bandwidth, so all I did was randomly do some sort of fraud transaction analysis. Today, analyze each and every transaction. I have the ability to do so let me analyze each transaction. That's where people are heading. Everyone is stuck at first deploying their Hadoop itself. Okay, unfortunately, that's where the world is. So what do you do? That's one problem. The second problem is scarcity of resources. I've already talked to you about that. You can't find people. It's impossible. Most of the best guys are risk modelers. 60% of them are in financial services companies. That's where the most sophisticated guys have been. That's where they get the biggest salaries, and everyone else gets nothing. So that's another problem. Business execs and data scientists don't understand each other. Okay, this is just you can't talk literally. It's to that level. So, I went to this data-driven marketing event, the first one, by the way, in New York, and everyone has heard of predictive analytics, and everyone is there, saying that something is happening. Let me also be part of it. But nobody has a clue as to how to utilize it. Okay, so these were our initial conversations where we went and thought that let me go and talk to them and understand what they want. I got nothing, literally. They just did not know what they want. Okay, so what did we do? We went somewhat in the same route as Andy, but in our own way, where we are now pre-building certain solutions using the community. Okay, so we would rather give you business solutions than try to explain to you how all of this happens. Okay, and nobody gets it. And usually you're selling to business users. Data scientists don't even exist, as I said, in most of these organizations. So for example, right, just a quick example, and there are many that we've gone through, and this is definitely resonating, which is, think of it, this as a simple, and by the way, even this is not happening yet, right? So you have social media monitoring, you have people filtering information so that you can respond to some of your customers. There are sites that provide what your competitor might be doing, which is of value, but nobody is trying to identify correlations in all of the various data streams. If you tweeted on Tuesday morning, what is the probability or of it getting retweeted, say 10 times or 20 times? Nobody is telling this. Okay, it's why, and that's the question. That question is more important, and that is because people are taking the tools approach. And a tool can take you only that far because there are plenty of correlations. What we are doing is in real time on our server, we have 20 digital streams constantly being streamed. We look at a slice of time and we tell you what impact your tweet is having on your Google trend, or what impact your YouTube video like is having on your retweets. This is something that's impossible because when a community looks at millions of correlations, there is a need for some human intervention at this point to identify which is the signal and which is the noise. And there is always, a model will give you a bunch of correlations. Correlations is easy. What is the junk in there actually does require a guy with a magnifying glass, and that's what we are trying to do. Okay, so this is one of the kind of business solutions that is resonating with clients. Similarly, we are doing climate analytics. We've done patent analytics. That one is a very interesting one, where we analyze 22,000 H1N1 patents around H1N1 virus. As you know, these viruses keep mutating, and hence the vaccine needs to keep updating. So it's a huge process, and it's a very costly process for these guys. What we did is we looked at these 22,000 molecules, and we identified the top 22 or 30 that should become the starting point for building the vaccine. We saved close to 4 or 5 months of time in doing so. Because look, the fundamental pharmaceutical research days are over. Okay, there are many patented molecules, and usually a new vaccine is an amalgamation of those molecules. So smart grid analytics, just helping you look at energy data. And for example, you have these smart meters now and it's going to come in almost every house. And the energy usage is getting recorded. You know the signature of each device in your house. So you know when the fridge got turned on, or when the light bulb turned on, there is a certain wave pattern that gets created. We looked at this algorithm and we tried to split those signals so that we can provide itemized, almost like a credit card statement. Can we provide an itemized energy usage bill to you, where an air conditioner, you know exactly which device is consuming more energy, so that you can improve on it. Or maybe an air conditioning company can come back and tell you, look, try this out for free, your consumption will go down. So that's again, and CRM analytics. So we've looked at online customer behavior. And so recommendation engines are good when you've already, basically, someone has already bought a product. Imagine you have a new product and you have a new customer. I can tell you what is the likelihood of this new customer liking this new product. So we've done that for an online. So we've done this now across industries. And we've worked in US and India. So I don't have experience in Asia, so I'm not going to talk about that. But in India, the core difference between US and India is the availability of data. Okay, the maturity and the availability of data is reasonably high in the US. Data is not easily available in India. And so the kind of problems we are addressing are very different as a result. In the US, for example, in marketing, we will focus on customer retention, churn, loyalty. In India, because there are two reasons. One is data is not available, and the second is it's a developing, evolving market. So they are more interested in, how do I acquire new customers? Can you get me data on that? How do I make my insurance agent more effective? So those are the sort of problems we are dealing with in India. But this is a quick summary and overview of what we are doing. Hopefully, it raises more questions than answers them.